Okay, so the other specs on this page, the hub diameter, hub thickness, shaft, and adapter rings. Okay, let's talk about those for a second. What is it even talking about? Okay, let's look at this. All right, so if I have a prop like this, right? Here's my propeller. We talked about the blade, diameter, and everything. But what about this center part here, right? If I have a motor, oops, I want to make sure the prop's going to fit on the motor, right? Okay, is it going to fit? Is the motor shaft going to go through far enough for me to put a nut on there? All those kinds of things are important, right, for me to make sure these work together. So, some measurements we often get, let me see if I can do this so you guys can see it, are the hub diameter. So this center part here in between the blades, okay, is called the hub. And if I measure the hub diameter, so measuring the diameter of that circular section there in the middle, we get 16 millimeters. And that's what the product manufacturer also stated. Okay, that's the hub diameter. Right, here's the hub thickness. So top to bottom, how thick is it? Try to turn it a little bit here so you can see what I'm measuring. Okay, I'm going to measure how thick that is. Okay, and if we hold it like that, we get about 8.5 millimeters perhaps. I think that's what the manufacturer said, 8.5. We can double check in a second, but that's about how thick I'm measuring here with my micrometer as far as the thickness of the hub. Okay, so with those measurements, we would be able to tell even before we bought the prop, right? That's important. Before we buy it, we can tell, well, is this going to be the right fit for my motor? Is it going to be too big, right? Is it going to fit on the motor shaft, right? We can't obviously put this kind of a teeny motor on this prop. That's not really going to work, okay? The motor shaft's way too small. The prop itself has the hub about the same size as the motor that we're trying to use, so that's not going to work very well either, okay? But sometimes you come across things like this with this motor where you're like, okay, I could probably make that work with an adapter ring, which we'll talk about in a second, as far as the motor, the size of the hole inside here. But look, it's kind of tall, kind of thick for this motor shaft. I'm not going to really be able to get a nut on the end here to tighten that down. It's just not going to work probably. There's not enough thread sticking out. So the thickness of this hub is too thick for this motor. Okay, even though the diameter might be okay. All right. That last piece I mentioned there, as far as fitting this onto the motor shaft and not having it move around so much. Oftentimes with motors, you'll get a set of adapter rings. We can see some of them kind of shake some of these. Oh, here's a set right here. So this prop comes with these adapter rings here. They're kind of like a little thing from a six-pack. Okay, the little plastic part you pull off maybe. Okay, you can grab those adapter rings and you can fit those. They all fit in the prop, right? But then you find the one that fits on the size of motor shaft you have. Because the motor shaft might be like 5 millimeters, or it might be 6 millimeters, or 8 millimeters, okay? And the prop has obviously a maximum size. The hole can't get any bigger than what it already is, but it can get smaller than what it already is with these adapter rings, okay? So I would take my adapter ring, let's see, like one of these over here, and say, okay, which one fits on my motor? And the one that fits I think is missing actually, but we'd say, okay, this one fits. We'd fit it onto the motor shaft, say, oh, that's the right one. And then we'd take the adapter ring out and pop it into the back of the prop or the front of the prop, depending on which way you're mounting it. And that would help the prop to then be nice and snug and not be able to kind of wobble up and down or side to side on the motor shaft, right? We want it to be nice and sturdy on there, and then we'll tighten it down with a nut. But that would prevent that wobble because it would be the right size for this motor shaft. Okay, that's what adapter rings are for. Sometimes they're called prop bushings as well, I believe. Sometimes people refer to them as prop bushings. But you should get one of those with pretty much every prop you buy. If you buy from good manufacturers, they'll include them with the prop just like that in the packet. Okay? All right. Let's go back over here. Okay, so we should have gone through all of these now. We have the hub diameter. We talked about that hub thickness. Yep, that was 8.5. We have the shaft and the adapter rings, okay? And so we have all those pieces of information that help us determine what the prop will actually do, what it will fit on before we even buy it. So that helps us make a good decision when we're buying things. All right, next up, let's talk about a little bit more about naming conventions, and that will wrap us up with the propellers here. Okay, so in naming convention, we talked about this 9 by 4.5 before. Okay, the prop here, let's see. Here we go, 9 by 4.5. That's one way to name your prop. Okay, Up here on the PowerPoint, we have a couple other methods that are seen out there. There's not really a good standard, unfortunately, but these are often used by manufacturers to label their props. So we have an L times P times B. That's what we just saw, 9 by 4.5, okay? Length or diameter. P for pitch, so 4.5, and then B by number of blades. We did not have a number on that. It was just 9 by 4.5. Often, if you don't list the B, like if there's no number in that section of the prop's description, it just means it's a two-bladed prop. That's kind of the default, right? But if it was a 9 by 4.5 by 3, that would be just like we have now, except it would have 3 blades instead of 2. Okay? We looked at the example of that already. Folding props are also included in this. So if you have a prop that folds, you still measure the prop basically overall, not just like 1/2, if that makes sense. There'll be some other measurements there to help you understand if the folding prop will work for your specific application or not. But typically, to my understanding, folding props are also included in this nomenclature. Okay. A couple other ways they might label props are these other ones over here. We have LLPP times B, so length, pitch, number of blades. And we have LLPP, assuming you can see the prop or the blade number, or LLPPB, all one number. Okay, we'll look at an example of that here in a second, but basically they're all talking about length, pitch, and number of blades, no matter what. But you may have them written different ways. So let's look at an example here on the PowerPoint slide. Okay, so here we have a DYS XT30453. What is that even talking about? Okay, the DYS is just the brand here. XT is just another kind of marketing thing. But what we really care about is the 30453. Okay, so if we go back here, this is an example of this basically. Length, length, pitch, pitch, number of blades. Okay, and when it says length, length, pitch, pitch, you can put a decimal point in there typically between each of those. We could say like this. Okay. And that would help us maybe decipher a little bit. I'm not sure. Okay, let's see what you think. But a 30453. So what this is saying is 3.0, so 3 inches in diameter. Okay, the prop is a 3-inch in diameter prop. Okay, 4.5, so it's a 4.5-inch pitch on the prop. And the last number there, 3, refers to the 3 blades on the prop. Okay, so hopefully that helps a little bit. Let's go back to this. I'm going to take out these decimal points here because they're not in the real thing. You just have to kind of infer them. Okay, let's look at a couple examples on the .chem. Okay, so here we have a couple of this is more commonly done on 3 or more blade props that are used in the race quad world or the racing drone world. Okay, let's look at this blue one first. All right, so we have 3 blades, of course. Okay, I'm not sure if you'll be able to see this. Let's see if I can get it to show up on the .chem. All right. There we go. See that little engraving kind of right there? It's going to be hard to see with the reflection and stuff, but basically what it says is T5040C. Okay, T5040C. And what that's saying is basically 5040 is just like we talked about, so 5.0, 4.0. So it's a 5-inch in diameter prop. Okay, so we go diameter here, 5 inches in diameter. The blades are at a twist to be a 4-inch pitch. So one rotation through a solid, okay? It's going to move forward 4 inches, right? Okay. And we know it's a 3-bladed prop because we can see it. So they did decide not to put that on the actual prop. Okay. The TC is probably just a marketing thing, I would imagine, with these props. Let's go back here and see if we can see it again. TC, let's see, 5040. And the C may be to designate counterclockwise. I'm not positive on that. But the important part is the 5040, and we can see what that signifies here, as well as we can see that it has 3 blades. Oops, bumped my camera there, sorry. Okay, let's look at another one. This one here, this yellow one, let's see if it has it right. And so this one doesn't actually have it labeled on there. All it has labeled, if we can get it to focus there, it says Nazgul F5. That's all it has labeled on the prop. Okay, so not all manufacturers label them as you might like, but from the specs of this prop, I can tell you it's a 5-inch in diameter, 3-inch pitch. Okay, so less pitch than the blue one. See if we can compare those a little bit. They're opposite rotations. No, they're the same rotation, so maybe we can compare them a little bit here. Let's try stacking them. Okay, so if you see that, you can see the blue blade is twisted more than the yellow blade, perhaps. You can see that. Okay. And then we can see the yellow one has a three-blade propeller, so we don't need that extra number 3 on there either. Okay. As a different manufacturer will do a better or worse job of labeling things. This one here is interesting, right? It's actually not labeled on the blade, it's actually labeled on the hub. We're going to flip it over here on the bottom of the prop. And if you guys can see those engravings there on the bottom of the prop. Okay. They got a 5040 and a RK. I think these are racecraft propellers, craft with a K. So the RK is for the brand. And let's turn it this way. We have a 5040. Okay. So again, this is a 5.0, 4.0, so 5-inch in diameter, 4-inch pitch on the blades. However, this is a 4-bladed propeller instead of 3. Okay, but they decide not to designate that in the number, just to assume that you can see a picture of it before you buy it, or read the product description, or whatever, and you'll know that it has 4 blades. Okay, so those are smaller props, all for kind of racing quads, and you see the variety of manufacturers' labeling techniques, some better, some worse, but hopefully with the information you've been able to gather out of the slide here, okay, you can decipher most any prop that you'll come across, understanding that the length, then pitch, the number of blades is typically the order, whether they write it out with X's in between or crush it all together just in one big number like this. Okay. So that kind of wraps up our discussion on propellers here. We'll hopefully that'll help you with your propeller assignments in class, as well as understand more about propellers as you might buy different ones in the future for your different drones and things like that. And thanks.